12 billion years ago, our universe was forged in the Big Bang. It created countless galaxies, the birthplace of stars and planets. Our own star, the Sun, and its system of 9 orbiting planets, was born over 7 billion years after the Big Bang. This man is about to take a trip into the depths of our solar system. Without even leaving the Earth's atmosphere, planetary astronomer Richard Terrell is on a journey to explore the origin of our planets. He's come here to the heart of the Mojave Desert, one of the driest and most barren places on Earth, to search for meteorites, rocks from outer space.
Meteorites are phenomenally important because they're really the only samples we have of what's out there, except for the moon rocks that we've collected. They're objects we can place in our laboratories. They can tell us what the raw ingredients were that formed the Earth and the planets.
Space is not as empty as we think. Each day, the Earth sweeps up over 20 tons of space debris. These are shooting stars, small lumps of rock captured by light-sensitive cameras as they burn up in the Earth's atmosphere. Usually, large meteorites break into many smaller fragments. They can land anywhere on Earth, but it's only when they land on an ice cap or a desert that we can find them. Meteorites are the builder's rubble from the greatest construction site of all time. They're fragments left over from when the planets were born.
The meteorites really tell a fantastic story. Most of the meteorites are incredibly old, dating back to the origin of the Earth and the Sun. They're really telling us the entire chemical and organic history of the material that formed the planets and give us a great deal of insight into our origins and the origin of life.
By radioactive dating of the minerals in these rocks, astronomers have been able to work out that the Earth and all the other planets were created 4.5 billion years ago. The solar system started life as interstellar gas and dust, a giant disk spinning inside the Milky Way. As gravity pulled the fine grains of dust together, a disk hundreds of billions of miles wide began to spin and collapse. At its heart, the material was so dense, nuclear fires ignited our sun. The heat of the new sun blew the lighter gases away to the edge of the disk, where it condensed to form the outer giant planets. At the center were small, heavy planets rich in iron. These new, young protoplanets were bombarded by the debris.
In the inner solar system, where we have 4 planets today, there were between 50 and 100 protoplanets, young planets, that ranged in size from about moon size to Mars size.
Our own planet was about to experience a traumatic birth. It lay directly in the path of another protoplanet.
And this is a body that's comparable in size to the Earth. So it would not be as if there was a small object in the sky. As it got close, it would literally fill the entire sky.
There was no escape. A collision was inevitable.
If this impact were to happen today, there would be no place to hide. This is truly a cataclysmic event.
The impact energy was so enormous, both protoplanets were melted. The liquid cooled, and the Earth was reborn. Orbiting around it was another new, smaller world, our moon. It gave us a target we could reach, a possible stepping stone from which to explore further into deep space. Without the proximity of our nearest neighbor, we may never have started to explore space. In 1961, President Kennedy used the moon to set the greatest challenge in history.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Even the astronauts of Apollo 11 believed there was only a 50-50 chance they would return safely from the moon.
We choose to go to the moon. We choose to go to the moon and do the other things, not because they are easy, but because they are hard.
To reach the moon, NASA created the most powerful rocket they'd ever built, the mighty Saturn V.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
The world held its collective breath as the three men set out on the most daring adventure of all time.
Houston, Apollo 11 and Saturn gave us a magnificent ride. Roger, 11, we'll pass that on, and it certainly looks like you're well on your way now.
The astronauts traveled 240,000 miles in 4 days. From their tiny windows, they looked out on a world pockmarked by millions of impact craters.
You're go for landing, over. Roger, understand, go for landing.
To avoid landing on rough ground, they aimed for a large flat plateau, known to generations of astronomers as the Sea of Tranquility.
Okay, engine stop. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. It's one small step for man, one giant leap for mankind.
The date was July the 20th, 1969. Man had taken his first step towards the planets. Over the next 3 years, 5 more Apollo missions landed on the surface of the moon. Only 12 men have walked there. The last man to stand on the moon was the commander of Apollo 17, Gene Cernan.
That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
Just the fact that you are there. You are on another body in our universe that is different, distinctly different, separate from our Earth, makes it overpowering. You know, here I am where no man has ever been before. Nobody has ever walked where I'm walking. No one has ever seen the mountains and the valleys and the boulders that I've seen. That makes it beautiful. That makes it special.
The lunar surface is covered in fine powder. It's the legacy of billions of years of pulverizing impacts. Beneath the powder, most of the crust is made of ancient rocks formed when an ocean of liquid magma cooled over 4 billion years ago.
Because The bottom of the core is not smooth. It's very jaggedy and fragmental-like. 9, proceeded. 3, 2, 1. Ignition. Right away, Houston. Vector grid. Bags off.
Apollo had cost America $24 billion. The American public was tired of paying for expensive manned flights.
We were the last mission of Apollo, and I knew that I'd be the last man to have left my footprints on the surface of the moon. But I never believed, ever, that I'd be standing here over a quarter century later and still be the last man to have walked on the surface of the moon. I think in one sense it tells us what we have not done over the last 25 years as much as it tells us what we have done.
Four days after leaving the moon, Apollo 17 safely re-entered the Earth's atmosphere. This was the end of the Apollo program, the end of an era. Over a quarter of a century after the last astronaut left the moon, NASA launched an unmanned probe. In 1998, the Lunar Prospector probe was sent to detect any resources that might be useful if we ever wanted to return to the moon and build a permanent base. One of its tasks was to search for water by sniffing for hydrogen particles from a height of up to 100 miles above the lunar surface. Lunar Prospector spent 9 months orbiting the moon, scanning every square inch. Its search was not in vain. As it flew over the poles, it detected hydrogen atoms, probably from water frozen below the surface. Lunar Prospector had found a resource that could revolutionize space travel.
Ice is important because you can break ice into its component pieces. You can make ice into hydrogen and oxygen. And hydrogen and oxygen are the primary components of rocket fuel.
Most rockets are powered by liquid hydrogen and liquid oxygen. If we could mine ice from the lunar surface, we could turn it into rocket fuel and use the moon as a launch pad towards the planet.
If you would have the materials that you need in space already in space, you've saved a lot of money. So that makes the 10 billion tons of water worth trillions and trillions of dollars. And nations have gone to war for a lot less.
Lunar astronauts of the future could be mining engineers. The water ice that Lunar Prospector detected is most likely frozen underground in craters near the poles that lie in permanent darkness.
It allows you to use the moon as a filling station. You can stop at the moon, you can use the ice to make hydrogen and oxygen and refuel your rocket and basically go anywhere you want.
With this bonanza of cheap fuel, our descendants will be free to roam the solar system and search for the next planet that we might call home. At the end of its successful mission, Lunar Prospector was sent crashing into the lunar surface. When it struck, it was traveling at almost 4,000 miles an hour. The solar system is vast. There are 9 known planets. The giant outer planets orbit billions of miles out from the sun. The human race has evolved by taking risks, conquering new environments. But sending astronauts out here will take generations. The only way we can visit these planets in our lifetime is by sending robotic probes. Inside the asteroid belt are the 4 rocky terrestrial planets: Mars, our home, Earth, And inward towards the Sun are just two planets we could try and visit: Venus and Mercury. Mercury orbits just 36 million miles from the Sun. Inside, it's made of 70% iron, far more dense than the Earth or the Moon. In 1973, NASA sent Mariner 10 to photograph the surface of this harsh and remote world. The pictures it sent back revealed that, like the Moon, its surface was heavily cratered, battered by asteroid and meteorite impacts over billions of years. With virtually no atmosphere to protect its surface, Mercury bakes at over 400 degrees Celsius in the day and freezes at minus 183 at night. Venus proved even more inhospitable. In the 60s and 70s, both the Soviet Union and America raced to find out what was hidden below the thick layer of clouds. Armored like a tank, the Soviet Venera 9 survived the descent through the sulfuric acid clouds just long enough to transmit a picture of its base sitting on the scorched rocky surface. In the 80s and 90s, orbiting spacecraft used radar to penetrate the acid clouds and map the surface in detail. Without even setting foot on the planet, scientists had seen a landscape beyond their wildest imagination. Its surface is littered with volcanic cones and lava flows. The temperature on the surface of Venus is hot enough to melt lead. The atmospheric pressure is so great it would crush a tin can. It's unlikely that we would ever want to set foot here. It may be well into the 21st century before we can visit even the more hospitable of the planets. For most planetary scientists, the best method of trying to understand what conditions are like on the surface of other planets is to compare them with the similar terrain here on Earth. Our planet is peppered with volcanic structures, features that can help to unravel the mysteries of distant worlds. For John Spencer from the Lowell Observatory in Flagstaff, Arizona, this flight over his local volcanic lava field is like flying over Venus or Mars.
We're now looking at another absolutely gorgeous example of a cinder cone and a lava flow. You can see the crater in the center and the big pile of cinders around the outside, and then coming out here at the base and spreading out for several miles is a thick lava flow going to other planets where all we can really see is the shape. We can't go down on the surface and sample the rock. We can still tell what the composition of the volcanoes is and something about their history just by looking at their shapes.
This group of recently active volcanoes in northern Arizona has spewed dark basaltic lavas from beneath the Earth's crust onto the surface.
Seeing lava flows coming away from craters like this is a surefire sign that we're looking at volcanic activity, whether we see it here on the Earth or whether we're seeing it elsewhere in the solar system.
Volcanoes help create the oceans and our atmosphere. If we can find volcanic structures like this on Mars, we can speculate that once it may have looked more like Earth. When the first spacecraft flew past Mars, the evidence for volcanic activity was unequivocal. Images beamed back revealed structures very similar to those the scientists could see on Earth. These cones are thought to be dead now, but the evidence of an active past is everywhere. Mars boasts the largest volcanoes in the solar system. This is Valles Marineris, the largest rift in the solar system. If it were here on Earth, it would stretch across the Atlantic. It's a giant scar, evidence of a dynamic past when the Martian crust was torn apart. This is the Jet Propulsion Laboratory at Pasadena, California, home of NASA's unmanned space missions. The task of getting the first mobile rover to land safely onto the surface of Mars was the responsibility of JPL's Rob Manning. Manning and his colleagues had spent years designing and building a new robotic rover called Sojourner. It would be the first vehicle that NASA had landed on another planet for over 2 decades.
Going to Mars for the first time in 20 years was a challenge because a lot of the people who knew how to go to Mars and land on Mars were dead or retired. So we had to go back to the drawing boards and really figure out, again, from first principles, how to bring a lander to another planet.
Manning's young team decided on a radical new way to land. To save money, Sojourner would be dropped down onto Mars inside inflatable airbags.
The Delta rocket with Mars Pathfinder, and the vehicle has cleared the tower.
After a 7-month flight, the Pathfinder mission made its final approach. Manning and his team were about to discover if their unique method of landing would work.
The next event is lander separation. That should occur in about 5 seconds.
Sojourner rocketed down through the thin Martian atmosphere and survived at least 15 bone-jarring bounces. Sojourner had come to a stop precisely on target. Years of hard work had paid off. For Manning, it was a moment of pure ecstasy. For the first time in a generation, NASA had returned to Mars.
Once the pedals opened up, and the next day, when we finally got Sojourner to stand up and roll down the ramps, for the first time, we had a mobile robot, a mobile laboratory, a mobile geologist that go out and explore another planet.
For the men and women who drove Sojourner from tens of millions of miles away, this was the next best thing to being there.
Operating your rovers and lander on another planet, it feels like an extension of yourself. You really feel that you are there. Every day when we came to work, we went to Mars and we saw it for ourselves. It felt like an extension of our hands and eyes. And so it was very exciting. We knew what that landing site felt like to be there.
The Pathfinder mission had landed Sojourner in an area thought to be an ancient floodplain. As it roamed the surface for 84 days, it examined the boulders and discovered that Mars was covered with many different types of volcanic rocks. In 2003, NASA plans one of their most spectacular of all missions. This flight will happen exactly 100 years after the Wright brothers flew their first plane on Earth. The Mars airplane will fly to the most inaccessible regions where life might have existed and photograph them from the air. For some people, robotic explorers aren't enough. They believe that true exploration can only be made by humans.
Have you ever seen a robot have a ticker tape parade in New York City? No. That's the big difference. We must go. It's within us to go. The question we ask about what is it like, what does it feel like, what does it look like, are questions people can relate to only through a human being, not through a robot, not through a camera, not through a computer chip.
As early as 2020, there might be a manned mission to Mars, the first to carry humans to another planet. Traveling to Mars will be a huge risk. It will take 9 months just to fly there, a round trip of at least a year and a half.
We will settle Mars, we will live there, it's a sister planet, it's there, it's beckoning our call, and we will inhabit it very much like we inhabit the Earth. And I can't tell you why or how quickly. People are going to say, what about water, what about, it's all there. All we've got to do is go find it and make it happen.
Carolyn Porco is a planetary scientist whose professional career has coincided with the modern era of planetary exploration. She's devoted her life to the giant outer planets that lie beyond Mars.
No matter how you cut it, the vast majority of our solar system exists out beyond the orbits of the asteroids. Inside, you have 4 measly little terrestrial planets, Mercury, Venus, Earth, and Mars. And while they're very important to us, especially the third one, most of the solar system is way beyond us.
In 1977, 2 identical Voyager spacecraft were launched to Jupiter on a path that would then catapult them onto Saturn. It was a now or never opportunity that took advantage of an alignment of the outer planets that only happens once every 176 years. Voyager 1 was spun out of the plane of the solar system, but Voyager 2 was flung on towards Uranus and Neptune. Voyager 2 sailed past Uranus at 40,000 miles per hour. It made its final rendezvous with Neptune after traveling over 4 billion miles. The Voyager spacecraft were the most sophisticated machines of their time. Their cameras would electronically record pictures, and their large white dishes beamed them back. The scientists knew that one day their spacecraft would fly beyond the solar system. They were keen to include a message for any curious aliens. Gold-plated LPs with greetings from every nation on Earth were bolted onto the spacecraft. They came complete with instructions and a stylus.
As the Secretary General of the United Nations, an organization of 147 member states, I send greetings on behalf of the people of our planet.
Silema Gemen, oitinis poteste chairete.
Paz e felicidade a todos.
各位好嗎？祝各位平安、健康、快樂。
Adanish Lushulmu.
ขอส่งมิตรจิตมาถึงท่านทุกคน
Hello from the children of planet Earth.
2 years after launch, Voyager approached Jupiter. It recorded this remarkable time-lapse image of the king of the planets spinning on its axis. Hard to believe that this giant gas bag could swallow more than 1,300 Earths. Jupiter's 4 largest moons, Ganymede, Callisto, Europa, and Io, were clearly visible as they orbited the planet. Here, circling the largest planet, was an entire planetary system in miniature.
I was one of those people standing in front of the monitors watching these images come down for the first time. Things we had never ever seen. People were lost for words. Very intelligent, bright people who'd studied planets their whole lives were lost for words. You know, I had the impression of being on the bow of a ship and, you know, entering uncharted territories and discovering things that no human had ever seen before.
Strangest of all were Jupiter's cloud tops. Here in intricate detail was the fearsome beauty of the Great Red Spot, a hurricane twice the size of the Earth, for some unfathomable reason has been raging for more than 300 years. Jupiter spins so fast that with a day less than 10 hours long, its clouds are drawn into streaks around the planet. Unlike Earth, its multicolored clouds are not powered by the sun. These storms of liquid marble are fueled by heat inside the planet. A childhood fascination with the king of the planets set amateur astronomer David Levy on a path that would help him discover a comet and predict Jupiter's most dangerous moment.
Well, I've been fascinated with Jupiter since the summer of 1960. That summer, I had my first telescope, and with my parents, I went outside, set it up, and looked up at the sky and saw the brightest star in the whole sky. Had 4 little moons and little bands across it, and I said, "Hey, that's Jupiter." It's the first thing I ever looked at through a telescope. And I think if that particular night, if my dad had said, you know, in 35 years from now, a comet with your name on it is going to go smashing into that planet, I would have been pretty surprised.
In 1993, David Levy helped discover an icy juggernaut that had roamed the back streets of the solar system for over 4 billion years. But Comet Shoemaker Levy No. 9 hadn't reckoned on the mighty gravitational power of Jupiter. The broken fragments were being sucked in by the largest planet in the solar system. Like bombers in formation, Shoemaker Levy 9 made its final approach. The fragments plummeted down through the endless atmosphere. On the 16th of July, 1994, the astronomers back on Earth watched the mighty flare as the first fragments smashed into Jupiter. The titanic collisions left a series of massive scars across the planet.
Jupiter is the solar system's vacuum cleaner. If Jupiter weren't there, those comets would still be running around, smashing into all of the inner planets, including the Earth. The Earth would be being hit by comets instead of once every 100,000 years, might be being hit every 100 years or every 1,000 years. And we couldn't be here. We couldn't live on an Earth that was being smashed by a comet every 1,000 years.
But it was Jupiter's moons that held the greatest surprise. When Voyager turned its cameras on the innermost moon, Io, it revealed the most active and dynamic body in our solar system.
At the time of the Voyager flybys of Io back in 1979, we got our first close-up pictures of Io from the spacecraft as it flew past. And one of the engineers saw these sort of weird clouds and were not at all able to figure out what this was, but eventually decided that this had to be something real. It had to be volcanoes that were blasting material off of Io.
For Earth-bound scientists like John Spencer, one way to interpret what the volcanoes on Io are made of is to compare them to similar volcanic structures we can see here on Earth. These fresh lavas are made of basalt. The shape of these flows bear an uncanny resemblance to features that Spencer has studied on the surface of Io. Since Voyager, later missions have photographed this festering world in even greater detail. Spencer believes that the volcanoes of Io seem to have erupted the same black lava we can find on Earth. Io is only the size of Earth's moon, yet its largest volcanoes are hundreds of miles across. Because of the low gravity, they spew lava hundreds of miles above Io's surface. Io's close proximity to its parent planet Jupiter exacts a heavy price. As Io orbits around, it's stretched and squeezed by the immense gravitational forces.
The reason there are volcanoes on Io is because Io is very close to Jupiter and it's distorted quite a lot by Jupiter's gravitational field. Sometimes it's closer to Jupiter, sometimes it's further away. And when it's closer, it's stretched out, and when it's further away, it relaxes. So continually, once every orbit, Io is being squeezed and deformed, and that just puts a lot of heat in the interior. And that heats up the interior to the point where you have volcanoes on the surface.
As Voyager left Io, it captured real moving images of the first active volcanoes we had ever seen beyond the Earth. Voyager's next port of call was Saturn. It had taken the two probes over 3 years to reach here. Even from Earth, the rings are clearly visible, but Voyager discovered that they were wafer thin. They're composed of millions of separate rings, each made of countless fragments of rock and ice. Above them hover strange dark shadows, thought to be grains of dust swarming in Saturn's powerful electromagnetic fields. Slightly smaller than Jupiter, Saturn is still 750 times bigger than Earth. And like Jupiter, it's orbited by its own mini-planetary system of moons. Mimas, Rhea, Dione, with a count of over 18 moons, Saturn has the most moons of all the planets. The Voyagers were only able to spend a few precious hours photographing Saturn and its moons in detail. Carolyn Porco and her colleagues recently videoed their last farewell to a new probe to Saturn, Cassini. They had spent years designing a machine that will spend the rest of its life endlessly orbiting and photographing Saturn.
Cassini will be, once it pulls into orbit around Saturn, will be the farthest outpost that humans have ever dispatched in the solar system. And it will be the closest look at what still is for us a very exotic environment.
6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. We have cleared the tower. Pitch program is in. Roll program is in.
To see Cassini, this spacecraft that many of us had spent 7 years of our lives working on, designing and building, to see it get launched atop this gleaming white rocket, which rose from the launch pad, and it made this beautiful sweeping arc across the eastern sky, and then it was gone. I mean, it was literally gone. It left the Earth.
Stand by for solid rocket booster separation at 2 minutes. And the Cassini spacecraft is on its way to Saturn.
Named after the 17th century astronomer who first discovered a gap in Saturn's rings, the Cassini probe will arrive in July 2004. Cassini will also visit the largest of Saturn's moons, Titan. This orange orb is wrapped in a thick atmosphere. What lies below is anyone's guess. But there are tantalizing hints its surface may be covered with oceans of methane, crammed with the building blocks of life. Cassini will target and release the Huygens probe towards Titan. This probe is built to withstand landing on either an ocean or solid land. It will transmit back any signs of organic molecules from this unknown world. Voyager 2 reached Uranus early in 1986. It was 9 years since it had left the Earth. Uranus is colored blue because its atmosphere contains traces of methane. It's a featureless, cold world, but Uranus is different from all the rest. It rolls around the sun, spinning on its side, possibly because of a giant impact in its early life. Uranus is encircled by at least 11 incredibly thin rings of ice and dust, which Voyager showed us clearly for the first time. Last of the gas giants was Neptune, a giant blue sphere 2.8 billion miles from Earth. It was August 1989. Voyager had taken 12 years to reach here. It's so far out that it takes Neptune 165 years to orbit the Sun. It was remarkable that Voyager could photograph Neptune at all. Out here, the sunlight is only 1,000th as strong as it is on Earth. Like Jupiter, there is no solid surface. It's all gas, covered in layers of storm clouds. These are the fiercest storms in the solar system. The winds blow across the surface of Neptune at 1,400 miles an hour. Voyager's final task was to visit Neptune's largest moon, Triton. Across its surface were a field of ice volcanoes, where dark frozen nitrogen had spewed out onto the surface from underground. Our solar system had saved up its most bizarre object till last. Its task completed, Voyager left Neptune behind, hanging in cold, dark, empty space. It wasn't until the launch of the Hubble Space Telescope, above the Earth's atmosphere, that we could get a clear view of the furthest planet in our solar system. Hubble gave us our first view of this icy planet and its moon, Charon. Pluto is officially the 9th and last planet of our solar system. But recent research suggests that it might not be a true planet at all, but one of hundreds of thousands of icy worlds orbiting in a belt beyond the edge of the solar system. Pluto and its numerous cousins form a belt of debris that are the leftovers from the birth of our solar system 4.5 billion years ago. Planetary astronomer Richard Terrell decided that if he could find similar large disks of debris orbiting around distant stars, it might provide evidence that other planets were being created inside our galaxy. At the Canada-France-Hawaii telescope on the summit of Mauna Kea in Hawaii, Tyrrell is successfully searching for new planetary systems orbiting around stars similar to our own sun.
We're now finding morphology, very, very exciting structure within these disks. We're seeing rings, we're seeing cleared out gaps. All of these are real indicators that these disks not only are associated with planetary formation, but may even signal to us that planets have formed around these other stars.
After more than a decade of searching, Tyrrell has now discovered 6 disks orbiting around new young stars. For the first time, even the skeptics realize that our galaxy may be teeming with other solar systems, full of planets just like our own.
Most young stars will have these disks, which probably means that most stars have gone through the process which could lead, or probably leads, to planet formation. This is a tremendously important idea and leads to the conclusion that perhaps the majority of stars we see in the night sky, the majority of stars in our galaxy, contain planets.
The opportunities for discovering new planets will be endless. Future generations will be able to travel beyond the edge of our solar system and conquer billions of new worlds.
As we discover more planets around more suns in other galaxies somewhere out there in space, it's inevitable, as much so as me walking on a moon, that we will someday walk on those other planets.
Well, I think as human beings, we're always looking to explore the next horizon. And now that we've explored our planet, now we look up to the sky.
I know there are tremendous engineering challenges, and it won't be in my lifetime or, our children's lifetime, but eventually we will do it because we are designed to explore.
Quite literally, there are more stars in our universe than there are grains of sand on every beach on Earth. If you run your fingers through the sands on the beach and try to imagine just one of them being painted blue to represent the Earth and life on Earth, you'd have to be insane to think we're the only ones here.